We're going to be graphing equations in two variables. Here's an example. When you graph an equation, you want to graph all the points that make it true. For example, here, 2 plus 3 equals 5. So if x is 2 and y is 3, this is a true statement. We would write that as an ordered pair, and it could be graphable as an xy ordered pair as follows. Here's your x-axis, here's your y-axis. Here's 2, here's 3, here's the point where they have in common, and that is the ordered pair 2, 3 plotted on a graph. Now it's only one point that makes this true. 4 plus 1 is also 5, so if x is 4 and y is 1, this is a true statement. There's my ordered pair. Here's x equals 4 and y equals 1. Here's what they have in common, and that's another plot. Now there's no end to how many times you could do this. We'll do it a couple more. -1 plus 6 is also 5. So here's -1 on the x-axis, 6 on the y-axis. Here's where they meet. There's a third point. Now, if you kept doing this, you'd get a lot of points, and what you'd find is that they all make a line. That line, therefore, represents all the points where x plus y equals 5. Of course, we don't want to be guessing numbers when we graph things. It takes a long time in certain cases, so we want a shortcut. One shortcut to graph a line is using the concept of slope. Here's what slope is. Here's a line, and it turns out this line has a slope of 2. By the way, in math, m stands for slope. Why does it have a slope of 2? Because if you pick any random point on the line and go over 1 and up 2, you'll be back on that line. Here's another line. Notice that it's going downhill from left to right. It's going to have a negative slope. Turns out this line has a slope of -1. Why? Pick any point on the line, go over 1 and down 1, and you're back on that line. Here's another line. Notice it's going uphill from left to right, so it'll have a positive slope. The slope is 3/5. Why? Pick any point on the line, go over one space and up 3/5 of a space, and you're back on that line. Now, sometimes it's annoying to think of fractional spaces, so watch this cool trick. Imagine we were to repeat that multiple times until we were back on a lattice point with whole numbers. This would overall be the same as going over 5 spaces and up 3 to get back to the line. But sometimes we will think of a fractional slope as a run and a rise, how far you're going to go over and up to get back to that line. And that's sometimes the best way to think of a fractional slope. Let's use all that information about slope to graph a line. Suppose we were trying to graph this equation. The first thing that we can do is plug in a random 0 for x, which may sound strange, but watch what we're going to learn from this. If we plug in 0 for x, we get a y value. That y value is very important because it's where the graph crosses the y-axis, also known as the y-intercept. So now we know one point on our graph just from plugging in 0 for x. For that reason, we often call this last number the y-intercept. Strangely, mathematicians have chosen the letter b to represent the y-intercept. Reason? Couldn't tell you. Anyways, another thing that mathematicians have discovered is that the coefficient of x turns out to be the slope of your line. And we can use that to find the direction of where this line is going. Watch the graph. Because this line has a slope of 2, we can take the known y-intercept, go over 1 and up 2 to get a second point on the line. Once we have 2 points on the line, we know exactly where it is, and we've graphed this line. This trick only works when the equation is in that exact format, often called y equals mx plus b format, where m represents the slope and b represents the y-intercept. Let's graph this equation. Because this equation is in y equals mx plus b format, we can take the b value, or 5, plot that on the y-axis. Then we can take the slope value, or -3/4, and, starting from the y-intercept, go over 1 and down 3/4 of a space. This will give us the location of the line. A lot of students don't want to go 3/4 of a space down, so to avoid using fractions, we can do the rise over run trick. Take the number in the denominator and the number in the numerator, which is your run and your rise, and go over, and in this case down, that many spaces, over 4 and down 3, and that'll get us another point on this line. which gives us the same line we got a few minutes ago for this problem. Here's another example, and one thing you'll notice about this example is that it's not in the same format as the last problem where we did that graphing shortcut. In order to use that shortcut, we need our equation to be in the form y equals mx plus b. So I'm going to take the equation on the left and turn it into that format. To do that, I could add the x term to both sides, and then divide by the coefficient of y, and then simplify to get my graph to be in y equals mx plus b format. Once I've converted the equation to that form, now I can use the graphing shortcut. Here's my graph. We have a y-intercept of +4. That's here. And because our slope is 2/3, we're going to start at that y-intercept and go over one space and up 2/3 of a space. If you're not comfortable using fractional spaces, use the rise over run trick. Just from that same y-intercept, go 3 over and 2 up. That'll get you another point on the line, and it'll get you the answer to this problem. Let's take a look at graphing the line x equals -3. The first thing you should notice about this is that there's no y in the equation. But that's okay, there's a cool graphing trick. Watch this. Turns out it's just a vertical line at -3. But let me explain why. You'll notice that this is the x-axis, this is -3 on the x-axis, and that all these points have an x-coordinate of -3. Therefore, you can graph a vertical line through them, and you've just graphed that line. Next, let's graph the line y equals 4. First, let's notice there's no x in this equation. But it's easy to do the same trick we did before. It turns out to be a horizontal line. Let me tell you why. Here's the y-axis. Here's where 4 is on the y-axis. And all of these points have 4 as their y-coordinate. Therefore, the line y equals 4 is a horizontal line.